Hello, hi everyone. So this video would focus on naming complex molecules. Now this is a continuation, so I hope you have arrived at this point, having learned what is transitional metal, how is the electron configuration of transitional metal works, and the concept of ligands. Now we're taking it a little bit further from there. This is to basically identify a complex ion and be able to name it accordingly. Now, as all molecules, ionic molecules would be, a complex molecule would usually be made up of cation. Oops. Oop. Let me just change the brush down. Still a box. I need to change the brush. Okay, done. So cation, and obviously made up of an ion. In the case of this molecule, as the examples I have at the bottom here, you could either have a complex cation or a complex anion. In the first example here, we are looking at a complex cation. That's the positive ion that you're looking at here. And in the second example, we have a complex anion. Now, what makes it complex is the fact that it's made out of ligands. Now, just a brief introduction to the name. For example, here, hexa equal iron 3 sulfate. The hexa part here obviously refers to a number, and that stands for 6. And aqua, of the hex, yeah, sorry, not the hexa, hex. The aqua obviously stands for H2O, being the ligand here, and obviously the iron. Iron 3 is obviously we're referring to Fe3 plus, and the sulfate molecule is 4,2 minus. All right, and at the bottom here is potassium, obviously is K plus. Hex again, that would refer to 6. Cyan, Cn minus, and a iron 3 plus again. All right, that's an example. So in a while we'll look at how do we put it together, and how does it look as a complete ion, the formula of it. Now, how do we name it? First step, please identify the ligands. That's really crucial. Identify the ligands. I've already included a list of common ligands. You can see at the bottom part of this table here. I'm just going to put a tick right next to it. This is a snapshot taken from your textbook. You could refer to your textbook for this list. We will always identify the ligand. In this case, the ligand in this molecule, I'm underlining it again. You can see there's 2 lines here. It's aqua. Aqua obviously refers to water. And in this case, the ligand to identify here is cyano, which refers to cyan. Now, generally, you have to give the ligand a name. And we would add the alphabet O at the back to the root name of the anion. So in this case, for example, if it's a fluorine, and we would refer to it as a fluoro. If it's a chlorine, then it's chloro. Hydroxyl would be a hydroxyl, and cyan, which would be a cyano. As you get, neutral ligand, which means ligands that do not have charge. For example, water and ammonia would just simply refer to as aqua or amine. So the rest of the ligands that is charged, we simply add the term O to the root name. All right, so take note of this. This is really important. All right, this too is really important. Now we are looking at a prefix. We are trying to indicate the number of simple ligands. This is important. This prefix, you have to know how many ligands are there. For example, if you see the term aqua, that refers to H2O, and when we add the term hex, that is to show us the number of water molecule, or hexa. So mono when it's a single, di when it's 2, tri when it's 3, tetra, 4 penta, is 5 hexa, is 6 hepta, 7, and so on and so forth. Though it's usually very, very rare for it to go into hexa. So hexa equal iron 3 sulfate, potassium tetrachloro. So tetrachloro refers to the Cl minus, and then having 4 of it. Okay, so oxidation state of central metal ion is designated by a Roman numeral. So as you could see in this case, So it's Fe3 plus. So being Fe3 plus, we will use the Roman lettering here and assign the value of 3 to it. Sorry. More example, hexaequion, same example as above. 3, Roman letter, tetrachlorocuprate. Now, cuprate here refers to copper. I will come to that in a bit, show you why do we call it cuprate and not copper. Next step, if there is more than one type of ligand, then you will alphabetically go. For example, if you have a chlorine and bromine, obviously bromine would come first. So in this case, we have tetraamine dichlorochromium. Tetra is 4, amine obviously refers to NH3, and di is obviously 2, chloro in this case refers to Cl. So as you could see, there's 2 Cl here, and there is 4 amine here in the complex ion. Obviously, in this case, the complex is the cation, and then there's a chloride next to it, which is the anion. Remember from the start I've mentioned the cation could be complex, or the anion could be the complex one. Next step, if the complex ion is not a cation, in this case if the complex ion has a negative charge, then we add 8. So you have to remember, if the cation, we add a numeral, Roman numeral to its oxidation state. But in this case, if the complex ion is the negative ion, then we add the term 8 to it. For example, you could see that this is the molecule. I'm circling it right now. Okay, and this is a positive ion over here, and we see that this is the negative ion over here. So the metal in this is iron, but overall the complex here has a negative charge. So instead of it being ferrum, we will call it ferrite. Ferrite comes from the term ferrum, which is I think Latin for iron. So from ferrum, we'll change it to ferrite. Sorry. On the other hand, sodium hexafluorocobaltate, because you can see here it's a cobalt, and we have a negative ion again next to it. So from cobalt, it becomes cobalt-8. So the addition of ATE takes place at the back of it. So remember, this is for complex ion that has a negative charge. We add the ATE to the metal. We do not do that if it does not have. So in this case, you can see it has a positive charge. So the term chromium remains chromium. If it has a negative charge, then chromium would become a chromate. Clear? Okay, moving on. There's just one other thing that I would like to mention. So maybe I could do a quick recap. So cation is named before anion, fixed. Identify ligand. Make sure you choose the right name for the ligand. If the ligand is water, aqua. If it's ammonia, it's amine. And if it's anything else that's negatively charged, we add the O at the back of the root name: fluoro, chloro, hydroxyl, cyano, and etc. Some examples here available. Please determine the oxidation state of the ion, and make sure to include that as a Roman numeral. If the metal is located in the complex as a negatively charged complex ion, then we add the term ATE at the back of it. And one more, if there's more than one type of ligand, we will name it alphabetically. So amine comes first compared to chloro. Remember, the prefix, which is the numbering alphabets, will not be considered. It's the first alphabet of the ligand. And remember, there's one more thing that's not in the slide here. For example, the term tetra ends with an A, the term amine also ends with an A. When that happens, normally we do not repeat the A. As what you can see in this example, we do not repeat the A, we can just write tetra amine with a single A in between. Same goes to hexa. We use the term hexa, but if there is an A, for example hexaamine, then we do not have to repeat the A. Okay, that's it. It's actually pretty simple. It takes time to get used to, so please click on the next thing, and you may want to try some hands-on questions. Thank you very much, and sorry for the interruption with the cough. Still recovering. Have a good day.